Hi, friends. Welcome to our notes on the periodic table and how the periodic table is put together. So now we are finally getting all of these little pieces of the element puzzle put together with the periodic table. We got some learning to do today. So just like it says here on the notes, have your periodic table with you. You will be color coding as you fill in the notes. So you need a regular pencil and a red color pencil, a green color pencil, yellow, purple, orange, and pink. And that should take care of everything you need for your notes today. Here we go. And this is two separate assignments, by the way. You have one for your periodic table notes and one for color coding the periodic table. All right, so here we go. So first we're going to review the square information, because that helps us understand how the periodic table is put together. So if we remember, the number of protons in the nucleus is told to us by what part of this little square? Very good. It is the 47 here. For silver, that's the atomic number. That always tells us the protons. That's the number that never changes. AG, that is our element symbol. That's the 1 or 2 letter abbreviation of the element's name. And remember, the first letter is always capitalized, or a better way to say that is uppercase. The second letter is always lowercase. Then we have our element name, self-explanatory. Then we have 107.868. That is our atomic mass. And that is the average mass of all of the isotopes of atoms of that element. If I wanted to know the mass number for silver, I would round this to the nearest whole number, and I would get 108, and that would tell me how many protons and neutrons there are together in silver. So how does this relate to the structure and organization of the periodic table? Well, if you look at your periodic table, are you looking at it? Good. The atomic number and atomic mass generally increase from left to right and from top to bottom on the periodic table. So your lowest number is in the upper left-hand corner with hydrogen. Your highest number, and we have to talk about a few little things here, but really your highest number is oganesson, which is 118. Down in the lower right-hand corner, and I know there are a couple of rows below that, but if you notice, their numbers are not to 118. So we'll talk about where they fit in this set of notes today. All right, moving on here. All right, so what are these horizontal rows called? Well, the periodic table is divided into 7 main horizontal rows. And these rows going across the table are called periods. Now this little image only shows 6. I don't know why, but it has 7. So between 6 and 7, it's 7. So they're called periods. The number of valence electrons increases as you go left to right across a period. So the valence electrons tell us about the atom's reactivity, or how that element is going to react with other elements. So that's why we talk about them quite a bit, because that's what chemistry is about. It's about the reactions that go on between all the different elements in the universe. The number of each period represents the number of energy levels that have electrons in them for atoms of each element in that period. Okay, there we go. So, so if we notice, like we can enlarge this little picture a little bit. I'm going to look at it. These are for the first 20 elements. So we notice we have an increasing number, and that's all it's really trying to say. Your number of energy level increases as you get more electrons. So you start off with that innermost energy level having 2, and then you really get into energy levels that have 8, and then you just keep filling them with 8 over and over and over again. 8 is kind of a magic number when we are talking about energy levels and electrons. Atoms like to have 8 electrons, and that's why they make bonds with other elements. So that's just a little preview of chemical bonding. So there we go. All right. So, and there's a little picture showing you each period has a new electron energy level, some different images. This one is built off of kind of an older model called the Bohr model, where you have more than 8 electrons, but it kind of gets kind of complicated. So we'll stop there for now. All right. The 2 rows at the bottom of the periodic table, it says, are they periods or families? Actually, they're a little of both. So that's where we get into these little rows here at the bottom of the periodic table. So yes, these had to take a pause there for just a minute. So it's a little of both. So we're talking about these 2 rows at the bottom of your periodic table, and spoiler alert, the top row is going to be color-coded red, and the bottom row is going to be color-coded green. So here's how they work. Those 2 rows are actually separated from the main table, and they are part of your 2 favorite periods, which are 6, 7. That's right. Yeah, so each of these rows also share similar properties within the row. So we're going to talk about the top row first. Those are called the lanthanides. And if you notice, even on your periodic table, there's a little tiny, one of your little periodic table squares here. So, yeah, right here. It says lanthanide. So that's just to show where these 2 rows break away from the periodic table. And if you get a chance, look at my periodic table in the room, and at the bottom it would show what the periodic table would look like if those 2 rows were where they're supposed to be, which it wouldn't fit on a piece of paper. Honestly, that's kind of part of the reason why they're not there, is for convenience. So, and within each row, they share some of the similar properties. So these are called the lanthanides again. And here are some of the similar properties that they share. They are shiny. They are reactive, very reactive elements, and they're known as the rare earth elements. And that's not because there's not a lot of them. There's actually quite a bit of them in the earth. It's just they're really hard to get to. So that's what makes them rare. The bottom row, we're going to color code those green, and those stand for elements 89 to 103. And yeah, again, so they're called the actinides. And here's where we get into some unstable and radioactive elements. Like you may have heard of uranium before, when you've maybe learned something about radioactive elements before, or plutonium or thorium. Those are all radioactive elements, and those are the similar properties that the actinides share. So there we go. So take a break for a minute, look at your periodic table, and take a minute and do some color coding. All right, hopefully now you have your lanthanides color-coded red, top row, and your actinides colored green. So let's go learn some more. So groups, they are also known as families. And these are our vertical columns, so our up and down columns on our periodic table. So if we look across the top, those are the little numbers that are on the top of every column, not in the square, but above the squares. So the periodic table is divided into 18 vertical columns. Vertical means up and down. The number for the group or family is somewhere at the top of the column. Now, some periodic tables, there's a big line all the way across the very top. Some periodic tables break off hydrogen and helium and do a line across there and put the numbers. They all vary a little bit, but typically you're going to see something that shows the 1 to 18 group numbers in the periodic table. Elements within the same group have the same number of valence electrons. We've said this before, and remember those are important because they determine how elements bond or react with other elements. So there we go. So now we're going to get into some pretty, well, not yet here, okay? And how are the groups or families named? They're named either after the first element in the group, which we're going to see that here on the next slide, or the properties of the family. They react the same because they typically have the same number of, again, valence electrons. So yeah, so here's what it's going to look like when you're done, but this is just the check again. You should have these 2 rows done now, nothing else yet. We're going to get into the color coding. Actually, the little line and dot coding comes next. Okay, here we go, kiddos. So how are the groups or families named? I thought it would probably be easiest to put this on a chart for you, and how we're going to color code it. So we're going to start all the way at the left with the alkali metals, and we're going to put just a little dot up in their element square. So just to go back here, it's going to look like this. So you're just going to have little dots in their little element square. So let's keep moving forward here. They're group number 1. That means they have 1 valence electron. One thing to know is don't put a dot in hydrogen. Hydrogen is not an alkali metal. We're going to learn about it later, okay? It's kind of got its own little section on the notes. So one thing about the alkali metals is that they are very reactive. They are the most reactive metal group on the periodic table. Very, very reactive. Yeah, so that's group 1. Group 2 are called the alkaline earth metals, and they're going to have a little line across the top of their box, and you want to make the line so you can see them, but you still want to be able to read your boxes, okay? So that's important. So let me go back to that again. So there are little lines across the alkaline earth metals, and you can see all of my little coding. You can still see the element names. I didn't color so dark that you can't read your periodic table because, well, that wouldn't be very smart. We need to be able to read it. Okay, so moving on, alkaline earth metals, it's group 2. Not as reactive as group 1, but still pretty reactive. Yeah. So those are alkaline earth metals. Transition metals have the little slash from the corner to corner, just 1 though, because we're going to do 2 slashes here for group 18. So just 1 little mark diagonally from corner to corner. Those are groups 3 through 12. Their valence electrons vary. It depends. So they're very metallic, which means they're really good conductors of electricity. So that means that their electrons flow really well. And at any time, they can just have differing numbers of valence electrons. So what's true about them? Well, they are not as reactive as groups 1 and 2, and they are very metallic. Like typically when somebody says, hey, name a metal for me, you're probably going to go copper or iron or gold or silver. Well, those are all transition metals. So they have very, what we call metallic properties, and we're going to read or learn more about those and what those are specifically. We've actually learned a little bit about them already, but we have a slide just for metals coming up, or on metals, nonmetals, and that sort of thing coming up. So very metallic properties. And then moving on into the more boron groups. Actually, it is the boron group because they're not overly, I mean, there's a lot of stuff going on in them, but there's not one thing in particular that's a characteristic of the groups. So boron is just named after the first element in the group. We're not going to code those. We're just going to give them the code of whether they're a metal, a non-metal, or a metalloid. So that's coming up. Group number 13. Here's something though. We have 3 valence electrons for the elements in the boron group. And there's really nothing else to say about them. Carbon group. And I guess one thing interesting about these 3 groups is they typically have a metal. They have what's called a metalloid, and they have nonmetals all in the same group. So that does make them a little interesting. Carbon, 4 valence electrons. They're pretty reactive. Yeah, all of the elements in that group. But again, typically they have a non-metal, a metal, and a metalloid in those groups. And then we have the nitrogen group, named after the first element, 15. Those have 5 valence electrons. And then we get to the oxygen group. It's group 16. They have 6 valence electrons. Yeah, and that's oxygen. Pretty reactive group for nonmetals. I would say that's probably the second most reactive nonmetal group. And here we have the halogens. Those are very, very reactive. We are going to code those so we know what they are. So we're just going to make almost like a little kind of wide stance tic-tac-toe board with the middle square being really big. Okay, a little cross hatch on that. So that's our halogens, and they are group 17. They have 7 valence electrons. They are the most reactive nonmetals. And then we wrap back around to what we call the noble gases. We're going to put an X through those. They are group 18. And they have 8 valence electrons, and they are not reactive at all. So most elements will react with other elements so that they can get 8 valence electrons. Since the noble gases already have 8, they don't react with anything. But the other elements, they want to be what we call stable. So they want to get 8 valence electrons, so they get very, very reactive to do that. All right. Oh, also halogens are also known as halides. I guess I had that kind of off there. All right, so we've got that all filled in. So now let's do our check here. So we're going to do our color coding check-in. So we should have our dots, not with hydrogen yet, but we're going to put a dot with lithium, sodium, potassium, rubidium, group 1. We're going to put the little line across on group 2. We're going to put the little diagonal lines through all of the transition metals, and that stops here at group 12. Group 13, 14, 15, 16, we're not putting any lines in. And again, those have, you see that transition between nonmetals to metals. 18 has the little kind of wide stance tic-tac-toe board, and our noble gases have the X's. All right, moving on. All right, here we go. Here's where a lot of coloring happens, kids. Metals, metalloids, and nonmetals. So the periodic table is also organized by the metallic properties of the elements. Metals make up most of the periodic table, and we're going to color code it yellow. So yeah, there we go. All right, yellow. So again, metals have those what we call metallic properties. So what does that mean? They're shiny. They're malleable, which remember that means we can pound it into a sheet. And they are ductile, which means we can pull them into a wire. They are good conductors of electricity, and they are typically solids at room temperature. So that's what makes metals metally and metallic. Next, we have what are called the metalloids. So they're not quite metals, they're not quite nonmetals. They are found between and have properties of both metals and nonmetals. It includes boron, silicon, germanium, arsenic, antimony, tellurium, sometimes astatine, and polonium. So I'm going to have you color them all purple. They are solid at room temperature. They are what we call good semiconductors, which makes them really great to use in technology because you can control the electrical current on them way better than just a regular metal, which has a lot of, which are good conductors, but that helps us be able to control all of our little programming and the little on-off switching and all of the circuitry that's in all of the stuff that you love, especially your phone. So those are our metalloids. And last off, we have our nonmetals. We're going to color those orange. And aren't you glad we're almost to the end of the notes? But you're learning a lot, so let's keep going. They are found on the far right side of the periodic table. So they're pretty much kind of like, as far as properties go, opposite of metals. So they're dull, not shiny. They are brittle. They are not malleable. They're not ductile. They break easy if they're a solid. They are mostly gases at room temperature, so not solid. They are poor conductors of electricity. Don't get me wrong, there are a few that are solids, but most of them are gases. They do not conduct electricity well, but here's where they're really important. They are really important in your life. You can't live without them. You are made of them. So they play a vital role in living organisms. So carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, super important to living organisms. So super important. All right, so let's do our little check-in here. So we should have our metals. We're going to color them yellow. Leave our little lanthanides red and our actinide box green, so we kind of know where that is. Helps us understand it better. Our metalloids, we'll do those next, are purple. And then our nonmetals are orange. And there we go. Almost done. Got one little square left, which you may have already colored it, but you haven't learned about it. And that's our crazy little weird friend, hydrogen. All right, so what is it? Well, first of all, we're going to color code it pink. Here we go. Hydrogen has one valence electron, but does not really match the properties of any group. It's just there by itself. Hydrogen is a nonmetal, so it's over here with all the metals, but we stick it here because it has that one valence electron, like the metals in group 1, but it's not a metal. It is a colorless, odorless gas, so that's like a nonmetal. It is very reactive, very reactive. So we're going to color code hydrogen pink. We're going to fill in your little key up here. Don't forget to do that. That's something I look for when I'm checking your periodic table. And it looks like I made my favorite element holmium because, well, 6, 7. So you pick a favorite element and put a star or whatever you want with that and code that. Could be an element that's your initials. It doesn't matter. Anyway, hopefully you learned some things today. Hopefully that makes the periodic table more understandable for you, and we'll be learning more in a classroom near you. Thank you for listening.